Today we're going to talk about 2.1, and Unit 2 is all about inequalities. A lot of what we're going to be doing is really similar to what we did in Unit 1, except now we might not just have one answer, we might have an infinite number of answers that could be true in a particular problem, and we're going to be analyzing what that looks like. So 2.1 is on writing and graphing inequalities. So let's start with just what are inequalities? How do we use them? So inequalities are greater than, less than, greater than or equal to, less than or equal to. All of those are inequalities. If you see an inequality written out like x is less than 2, a solution to an inequality is any value that when you plug that value in, it makes that statement true. For example, if we had the statement x is less than 2, 1 is an example of a number that makes this true. 1 is less than 2. So is 0. So is -1. And you might kind of notice that there's an infinite number of numbers that would make this statement true, and we could not possibly list them all. And that's why inequalities come in. That's why we're going to talk about multiple ways to represent what an inequality looks like, all of which are still giving us the same information. So let's look at how we can represent an inequality. First, we're going to look at the words, then we're going to see 3 different ways that those words could be described using mathematical symbols. So the one that you have probably seen the most is actually the inequality. And when you're looking at that, so the words in this first part say x is less than 2. I learned at some point that the less than symbol kind of looks like an L. A lot of people have issues remembering which one is less than and which one is greater than. I also learned that the inequality, if you turned it into an arrow, it would point the direction that it would go on the number line. So this symbol right here is x is less than 2. I'm going to come back to the interval. I'm going to talk about the graph. So what I was just saying, that arrow, when you graph it, is going to point this way. It's going to point the direction that the inequality is, as long as your variable is on the left. And I always start by just doing whatever I need to do to get my variable on the left. It makes it much easier to work with. Something you might notice when you look at these series of graphs is that sometimes the circle is open or hollow. It doesn't have anything on the inside, and sometimes it is not. And the difference between those two things is when we're talking about or equal to, or we're just talking about less than or greater than. So an open circle means we are not including that value. So for example, this first row in the table says x is less than 2. That means it cannot be 2, which is why you don't see anything circled or filled in on the number 2, because it can be 1.9, 1.99, 1.999, but it can't be 2. That's why there's an open circle there. The last notation, and I'm going to kind of put a smiley face next to it, this is sort of your graduation notation. In future classes, you are predominantly going to be using interval notation. Anytime you're talking about an inequality, we're going to tie it to domain and range later in this year. But interval notation is just sort of fancier. It looks nicer. It's more concise. And the way that that works is anytime you're writing something in interval notation, I'm going to give myself a little space up here. Interval notation sort of looks like an ordered pair, except if you see in all these, there's the infinity symbol in there, and that should be a little odd. Interval notation always has the smallest a value can possibly be to still make this true, comma, the largest value that it can possibly be to still make this true. So if you think about x is less than 2 is going down forever. That's why you see negative infinity here. Negative infinity is as low as it could possibly get, and actually it won't ever get there, which is why there are parentheses on the edge. The largest value this inequality could ever be is 2. It's going up and up and up and up, and it's going to 2, but since 2 is not included, we use parentheses. Now, if you go down to the next line in this table, it looks really similar. The only difference is this big or equal to. So the way that shows up here is now there's a line underneath the inequality, meaning it could be 2. The way that that looks different in the graph is that the circle is filled in. It could be 2. It could be equal to 2. The way it looks different in interval notation is that you're going to have a square bracket, not a parentheses. So the square bracket means we include that number. Now this is still going down forever, and that's what tells me that I'm going down to negative infinity. The highest value is 2, and the lowest value is negative infinity. I sometimes think it's easy to think about interval notation when you're actually looking at the graph. So let's do that for the third one in this table. X is greater than 2. So at 2, I have an open circle because it's greater than, not greater than or equal to. It can't be equal to 2, which means that 2 is now the lowest number on the graph. It's not closed in, it's not filled, so we put parentheses. It's going up forever, so the largest it could ever be, well, there isn't a largest it could ever be, it's going to be infinity. Since we can't ever get to infinity, infinity will always be parentheses. So that kind of ties the graph and the interval notation together. The last one in here, x is greater than or equal to 2. Again, this is changing. Really, it's just having you look at now in interval notation. Since there's a line underneath the inequality, it's going to be a square bracket, and our circle is going to be filled in when we look at our graph. So something really important to understand, all three of these, inequalities, interval notation, and graph, all three of these are representing the exact same solution set, but they're representing them in different ways. But I think one of the most important takeaways from this lesson is that you understand that all three of these are representing the exact same words on the left. Now that we've talked about what inequalities, interval notation, and graphs are, let's talk a little bit about how do we do anything with them, and what are the how-tos of inequalities? And we're going to start first with how do we graph an inequality? So how do we graph an inequality? The very first thing you're going to do is you're going to graph the key point, which is the number that's involved in the problem. So the key point is just the number that we're talking about. Then you're going to, while you're graphing that, you're going to figure out, is that circle open or closed? Meaning, does it have a line underneath it? So these symbols would both be open, and the green symbols would both be closed. So identify that key value, determine if the circle is open or closed, and then make that circle. Then draw your arrow left or right. Remember, if your inequality has the variable on the left, then the arrow is going to point the same direction that your inequality points. If it's less than, it should point to the left. If it's greater than, it should point to the right. So before we talk about anything else, let's just do these three examples. So on number 1, I'm looking at the inequality that's there. X is greater than 3. So when I put numbers on the bottom, I want to make sure I have at least 3 numbers, and 3 is the most important number to be there. So 3 is my key point, open or closed. So I'm asking myself, is 3 allowed to be a part of the answer? It's not, because it says less than 3, not or equal to. So since there's no line under my inequality, I'm going to make apparently a very large open circle. Now, less than means I'm going down. So I'm going to shade on my graph to the left. That's all that we're doing when we're graphing an inequality. So looking at number 2, in your head, ask yourself, what is that key value? And should it be open or closed? So just take 3 seconds. What is that key value? And should it be open or closed? Okay, that key value is -1, and it should be closed because it says greater than or equal to. Now ask yourself, after you've plotted that point, should it go left or right? It should go to the right. There should always be an arrow on the end when we're talking about something that's going on forever. Number 3, I want you to try on your own, but before you try on your own, the very first thing you should notice is that your variable is not on the left, which means all the shortcuts, all the tricks that we just talked about don't work. To get it on the left, what you need to do is just switch everything around. So these two things are equal, but now we can use our tricks for the arrows, and everything else is going to be a lot easier. So go ahead, pause this video, identify your key value, and graph this inequality. Then unpause it and see how you did. All right, so that should be an open circle at 0 pointing to the left. Let's real briefly just now write these in interval notation. I want to tie the graph to interval notation. So I see that my arrow is on the left, which means it's going down forever, which means the left, the smaller part of my interval, is negative infinity. The highest this graph is ever going is 3, and that circle is open, so I'm going to use parentheses. On number 2, the lowest my graph ever goes is negative 1. And the circle is filled in, so I'm going to put square brackets. It's going up forever and ever, which is up to infinity, and infinity always has parentheses. And then on this last one, it's going down forever. That's negative infinity. The biggest it ever gets is 0, and it's an open circle, so we're going to use parentheses. So that's how you graph and also how you write in interval notation. The next thing we're going to talk about is how to write an inequality from a graph. So if you're given a graph, what do? Well, we're just going to work backwards through the things we just said. We're going to identify that key value. Depending on if the circle is open or closed, that's going to help us determine our sign. Then we're going to choose a variable. You can choose whatever variable you want unless the problem specifically tells you to use something. And write your inequality. So on number 4, my key value is the number 4. I'm going to just choose X. I always like to choose X. The open circle means that when I write my inequality, there will not be a line underneath it. And right here, I can see it's less than. That is my inequality symbol. So right here, X is less than 4. If I was going to write in interval notation, that's going to be negative infinity up to 4, parentheses on both sides because it's not filled in. Number 5, my key value is 2. My inequality is pointing to the right now, and there should be a line underneath it because the 2 is filled in. And then just for kicks and giggles, let's pick a different variable, y, on this one. You may choose whatever variable you would like. So we have talked about what an inequality is, how to represent it as an interval, as a graph, or using inequalities, how to graph them, how to write inequalities from a graph, and we are almost done. We just need to talk about one last thing. Some words that we often see that make it less clear if it's supposed to be less than or greater than, and then we're going to do one word problem and we're going to wrap up there. So when you see the words no more than means it can't be more than that. But what does that look like as an inequality? So let's say we were saying you can be no more than 5 years old to go on this kid ride at the fair. So no more than means you have to be that age or less. So age has to be less than or equal to that value. So when we're saying no more than, we're looking at less than or equal to as our symbol. Because you could be 5, you could be 4, 3, 2, 1, you could be any of those ages, but you can't be more than that age, less than or equal to. At least, similarly, at least sort of means the opposite of that. You have to be at least 36 inches tall to ride on a lot of rides at Disneyland. So at least meaning that number or more, greater than or equal to is our symbol there. All right, last question and then we're going to wrap up. Define a variable, write an inequality, and graph. Brandon's dad told him not to turn on the air conditioner unless the temperature is at least 85 degrees. Write an inequality that represents this temperature. So he must be at least, or it must be at least 85 degrees. So I'm going to say that T equals the temperature, and then I'm going to write my inequality. So the temperature must be at least. So my key number is 85. My variable is T at least. So it could be equal to 85 or it could be more. So the temperature must be T is greater than or equal to 85 degrees. That's the inequality that Brandon is using to be able to turn on the AC in his house. So I hope that you understand the symbols and the notation. If not, feel free to pause, go back, watch different parts of this video, and I will see you in class.